In this video we're going to be doing a capacity test on these LifePo4 lithium iron phosphate batteries, so stay tuned. Hey everyone, welcome back to Boating Tube. On this channel we do news, reviews, tech stuff, all to do with boating. So if you're new here, please consider hitting that subscribe button and ringing the bell for when we upload new videos. So in this video, as I mentioned, we're going to be capacity testing these 8 lithium iron phosphate batteries configured in a 2P4S 12 volt configuration. Now the batteries themselves are spec'd at 280 amps each, so wired in this configuration potentially could give us 560 amp hours, about 14 volts, 13 volts, 14 volts, depending on whether they're full or whether they're discharged. Now, a couple of notes before I run through the testing configuration and actually show you the test. So the capacity specification, according to the manufacturer's datasheet, is based on them starting off at 3.65 volts per cell and drawing them down to 2.5 volts per cell. This is the maximum and minimum specification that EVE, the manufacturers, recommend on these cells. Now, I don't want to push them that hard on their first outing, so what I'm going to try and do is get them to 3.6 volts once I've done the top balance, and then bring them down to about 2.8, 2.7 volts. So I'm not expecting to get the full 560 amps, but we'll do a capacity test. I'll run through the configuration and you'll see exactly what happens as we go through this. We've got the positive out of the battery here going directly into the inverter. The packs are wired in series, so there's a parallel pair, parallel pair, parallel pair, parallel pair, and then you can see it's wired then in series for each parallel pair. You can see the wires here, the balance wires coming off down here to the BMS. So this is a JBD 150 amp BMS, which I'm sort of trialing at the moment. Not sure if this is going to be the final one, but this is what I've kind of got to test at the moment. It's got Bluetooth, so we can kind of see what's going on. There's then a shunt, so 300 amp shunt wired into this. So the negative off the battery comes into B minus, and then here off the BMS into a shunt, and then the shunt negative to the inverter, which is a Sterling 1800 watt continuous, 2600 watt intermittent or burst. I've then got this little meter, which I picked up off Amazon, which is hopefully going to give us some kind of level of battery monitoring, so we can see how many amps we've taken out. It's also got low voltage disconnect, low voltage protection. Now I've set this to 10.8 volts, which is 2.7 volts per cell. I've set the BMS to 2.8 volts per cell, so technically the BMS should cut in first before this, but this is kind of then giving me a fail-safe if the BMS doesn't hit low voltage protection. I then have a 240 volt monitor connected up to the inverter, and then I've got a fan heater, which is going to be the load. Now this draws 1500 watts on level 2 and 3000 watts on level 3, so I'm going to use it on level 2 to draw 1500 watts. So that is the test setup. All a bit dodgy here, but that's what we're going to be going with. So time is now 12:30. As you can see here, we've got 14.43 volts in the battery, and we are drawing about an amp at the moment, and that's just literally running the inverter in standby. On the 240 volt side, we've got 0.6 watts there being consumed, and that's, I guess that's just running the actual power meter. So everything is ticking up, so I guess at 12:30 we will start the test. So that's, first of all, as you can hear, on fan only. Now that's drawing, what's that, 2 amps, 2.7 amps there. Let's just watch. See, ignore this this kind of battery level here, because I don't think that's accurate. It needs to kind of run a couple of times. So it's drawing 40 watts there at 2 amps, and we're drawing 18 watts there on the 240 side there. Let's bump up the power a bit. Now the heat is on. Now here's where we really start to get into business. So 123 amps we are drawing, 1.5 kilowatts on the 12 volt side on there, and you can see we're discharging and the watt hours going up there. So we will, and again we're drawing 1315 watts there. Check the temperature of the BMS, still pretty cool. Right, so we'll report back. We're about an hour in, and as you would expect, drawing 132 amps, we've drawn 134 amps. So we're just over an hour, so drawing 130 odd amp hours. Going to give us that fact. So an hour in, numbers looking okay. Voltage is down at 1179. Now, interestingly, this meter is giving me a different output to the actual battery if I measure it on the battery and if I measure it on the BMS. So I've got three different voltages at the moment. The BMS is stating about 12.3 volts at the moment, interestingly, and on the voltmeter about the same. I've had to jerry rig up a fan to cool the BMS because it was getting exceptionally hot. According to the software, it was getting up to about 67 degrees, and literally you could feel the heat. I mean, it is hot. I can leave my hand on it now. This bolt connection is exceptionally hot, but there's 130 amps running through that single bolt connection there. The inverter's warm, but again I can keep my hand on it. The fan is running on it. So clearly, if you want to try and pull 150 amps out of one of these Chinese BMSs, then you're not going to be able to continuously without putting some kind of cooling on there. I've actually even open the window in the room to try and get some better cooling in here. So yeah, just be mindful of that. But with the fan, temperatures come right down now to about 33 degrees on this now, and it seems to be running quite nicely. So we'll see how that goes. So again, check in about an hour, and that's where we are. Okay, back after the second hour, and as you would expect, we're now up to 262 amp hours, still drawing 127 now. Bit of an omission here. You'll see the voltage is now back up here at 12.43, whereas it was way down before. I didn't tighten down all the bus bars on the battery. When I checked, this one over here at the back was getting really warm. I mean, you can feel there's some warmth there, but they're not hot at all. I mean, compared to this, which is hot. So I went with a screwdriver and tightened everything down, and everything seems much happier now. All the cell voltages are much better. There is still a discrepancy between the voltage on this meter and the app for the BMS, so I'm not quite sure exactly which one's perfectly accurate. I have been measuring now and then with the voltmeter on each one of the cells to sort of try and get some kind of median average around this. Okay, we are 3 and a bit hours in now, still 12.25 volts, and we've done 420 amp hours, nearly 421 amp hours tick over there. Everything is still good. Still very warm on the BMS. Inverters warm, yep. The bars on the battery are not warm. I mean, they're not cold. There's temperature there, but they're not hot. Batteries themselves, actually, I haven't really checked those out. No, the batteries are all cold. There's no heat at all in any of the battery cells in there. My little dubious fan is still working on. I might crank up the power on that a bit. But there we go. Still going strong. 422 amp hours now after 3 and a bit hours. So we'll check back in later. 510 amp hours discharged, 510.74 there. You can see now battery is 11.94, so I think we're starting to stretch it out. In the BMS app, it's at 12.3, I think it is, but it's coming down. I can see one of the cells is just below or just below 3 volts now. So it'd be interesting to see if we manage to get to that magic 560 amp hour number, if we go past it or under it. So say 4-hour update, 511 amp hours so far. Right, this is a little embarrassing. We've hit about 4 hours, 45 minutes. Capacity was about 542 amp hours of total current draw. Now, as you would have seen and earlier on when I showed you through the configuration, I set the cutoff voltage on the BMS to be slightly higher than that of the meter. So what actually happened is the BMS did its job. It hit low voltage cutoff, powered off the system and powered off the voltage meter, and it completely wiped out all of the details. So I've turned it all back on and everything's gone back to zero, which is really frustrating. But certainly we hit 542 amp hours at a cutoff of 2.8 volts. Now, as I've mentioned right back in the start, these cells are based around 280 amp hours, going from 3.65 volts down to 2.5. So getting 540 amps going from 3.6 to 2.8, I think is a pretty good result actually. Now I'm going to do some additional capacity testing as we move forward. I've got to now charge these back up, which is going to take a while. I've only got a sort of 30 amp charger here at home, so it's going to take me a while to get these back up to power. Then I'm going to do some subsequent power testing, but initial tests, I'm really pleased to say 542 amps based on going from 3.6 to 2.8 I think is really good, and certainly, you know, way over my expectations of these batteries coming from China. So I hope you found the video useful. Please hit the subscribe and link button, and we will see you on more videos on Boating Tube very soon.